Hello YouTube and welcome to What the Math. In today's video we're going to be terraforming Uranus. That's right, start making those jokes and go. That was a pretty good one. Okay, let's stop that and let's actually talk about the pronunciation. It's actually not pronounced Uranus. It's the actual pronunciation, according to, well, pretty much every scientist out there, is Uranus. And if you go to Google Translate and you type the name and you click on pronounce, it will actually say
Uranus.
Oh, that's right, it's Uranus, not Uranus. So we've been pronouncing this wrong for the longest time ever. And that's mostly because it's more fun to say it that way. Anywho, so what are we gonna do today? Well, we're actually going to take a look at this awesome gas giant, also known as ice giant. I'm going to tell you a little bit about it, its history, its naming, and also its discovery, but most importantly, we're going to terraform some of its beautiful moons. We're going to turn them into Terra-like planets where we can one day live and prosper. Alright, let's actually start with, well, what is this place? What is this beautiful blue planet, and why, and where, and how, and what? Well, first, it was actually discovered in 18th century by William Herschel. He was one of the prominent astronomers in the UK, but he actually thought that this was a comet, and for the longest time he referred to it as a comet. And people were saying, dude, this is not a comet, this is a planet. And he was like, no, it's a comet. And eventually he was proven wrong, and he got to name it as well. He actually decided to name it George's Star, or George's Planet, after King George, the guy who basically gave him a bunch of money and let him stay with him in the palace. In this name, George's Planet, or I think it was actually Sirius Georgium or something like that, and this name actually stayed with the Uranus for a very long time, for something like 50 years, until in well, actually, only the British were referring to it as George's Planet because he was a British king and his name was pretty popular back then. But eventually it was actually changed, and a lot of people wanted to name it Uranus because Uranus is actually a Greek god who was the father of Saturn. And Saturn is actually a father of Zeus, and Zeus is obviously the Greek name for Jupiter. Jupiter is the Roman equivalent of Zeus, and Saturn is his father. So Uranus is basically the granddad of Jupiter, and this was kind of the notation that they used. So basically, because it's a granddaddy of Jupiter, let's name it Uranus. And he's also, I believe, the god of air. So Uranus is the god of air. So that's how the planet was named. And also the element uranium is named after the planet as well. Not related to it in any way, but just because it was found in a similar period where it was, it was discovery of science of all kinds. And the guy who discovered uranium decided to name it after Uranus as well. Now, just like other gas giants, Uranus has quite a lot of satellites. We currently know of 27 at least. There's probably more that we haven't discovered yet because we actually haven't visited the planet since 1986. But yeah, there's these inner satellites and also outer satellites right here. You can see them in the distance. So what is the difference? Well, just like with other gas giants, the inner satellites are in the same plane of orbit. You can see there's the same plane of orbit. They're also mostly rocky and somewhat hard and dense. Some of them have water, some of them have ices, but for the most part these are just rocky asteroid-like bodies. So especially these ones, the ones that orbit really fast around Uranus. Uranus also has 11 rings. There's a picture of it right here. So 11 rings that we found, very similar to rings of Saturn obviously, but much smaller. And all gas giants have rings, and this one is no exception. And so all of the satellites of Saturn, interestingly, have a very cool naming notation. So all of these satellites are actually named after the works of William Shakespeare and Alexander Pope. Both of them are British writers, and like, for example, we can, there we go, we have Ophelia from Shakespearean work, and Titania, Oberon are from Midsummer Night's Dream. There's a bunch of names from The Tempest, there's a bunch of names from King Lear, Hamlet. This is obviously from the Hamlet. And so all of these are actually not mythological creatures like they were with Jupiter and Saturn, but these are actually mythological creations from the British writers. And just like Saturn and Jupiter, the inner rocks are much smaller. They have a close to circular orbit, and they're sort of follow in the path of the rings of Uranus that you don't really see them. You don't see them here, but they are there. Then we have slightly larger moon-like objects, which are we have Miranda, Ariel, Umbriel, and Titania. These four. Oh, and also Oberon. These 5 satellites are much larger, but we're going to be taking a look at 4 of them. We're going to be looking at Ariel, Umbriel, Titania, and Oberon later on. And these are much larger, but still much smaller than other satellites around gas giants like Saturn and Jupiter. If you were actually to add them up all together, if you basically combine them into one large satellite, it would still be smaller than some of the larger satellites, and much smaller than even our moon. So that's how small and how not massive, how light they are. And then we have the irregular satellites, and these are also named after the works of Shakespeare and Alexander Pope. And these are the irregular orbiting satellites that don't actually have the same plane of orbit, and they have their own kind of a funky orbit. And these are much smaller rocks that are basically orbiting around Uranus. Now, there's another actually interesting feature about Uranus, and the feature is that it's actually the coldest body in our solar system, and the coldest planet, that is. It's the coldest planet, and interestingly, it doesn't actually radiate much heat. All gas giants radiate a lot of heat from the inside, and they actually even warm up their satellites a little bit. But this one doesn't. This one is actually really cold, and we don't know why. It's possibly because it's just kind of something inside blocks the radiation of the heat. And also, its orbit is very interesting as well. Not its orbit, but its actual rotation. So let me show you what I mean by this. Now, if you actually look at how it rotates around its own plane, so this is the sun right there, and here, if I were to zoom in here, you'll see that it's actually, here we go. It's going up and down in terms of actual day-night cycle rotation, day-night rotation. So it's going from here to there. You can kind of make it out, even though it's so dark here, but there we go. It's actually rotating this way, while every other, or almost every other planet does it sideways. So basically, if I were to take a look at, let's just say Saturn, this is how Saturn rotates in comparison. So it's going from left to right, whereas Uranus goes from top to bottom. So it's actually has a 90-degree kind of inclination to the sun. Also, unlike other gas giants, like this is, for example, Saturn, and let's look at Jupiter. And this is Jupiter, it doesn't really have any features. Like this is the most known feature from all gas giants, the huge spot of Jupiter. Whereas if you look at Uranus, as I'm going to call it from now on so that you don't make fun, does not have anything. It's basically just a featureless blue kind of a object that doesn't really have any features on it. And once again, we don't really know why, but it's obviously quite different from other gas giants. Now, unlike Jupiter and Saturn, and very similar to Neptune, it does have a very different composition. So this is actually known as an ice giant and not a gas giant. Or to be more specific, it's known as an ice giant, and not because it actually consists of mostly ice, but because of the material that it has inside. And these are, of course, things like water, ammonia, and methane ices. It does have a gas atmosphere as well. So there's actually an outer atmosphere with like a cloud layer and then there's another atmosphere with hydrogen, helium, and methane gases. But on the inside, it may actually have an ice sort of like structure, and then of course it has a Earth-like core with silicates and iron on the inside. But it's not as big as Earth. It's actually probably about 55% the mass of Earth, but it does have a huge ice-like structure around it, which is very interesting because only Neptune and Uranus have this type of structure. And what's even more interesting is that there has been some research that found that it's very likely that inside that ice-looking structure thing, there is possibility of having things like diamond rains and diamond-like icebergs. Basically, because of the pressure and the difference in composition, it's very likely that there's diamonds everywhere inside Uranus, and that's a possible thing that we can harvest in the future if we ever run out of diamonds on our planet. Now let's talk a little bit more about the satellites of Uranus. Let's start with Miranda. This is actually the closest to the ice giant, and it's only about 236 kilometers large, but it's one of the smallest objects in our solar system that is quite spherical due to its own gravity. So it's one of the smallest planetary-like planets, or objects, that is. And this one specifically has nothing really amazing about it. It's relatively light in comparison to other satellites of other gas giants. It has approximately 60% of its content as ice and not silicates. In other words, it's basically mostly ice. And also, due to its tidal heating and tidal forces from Uranus and other satellites, it's very likely that inside it might actually have some liquid ice, you know, because it's heated and pressurized due to gravity. But other than that, there's really nothing special about it. It's very kind of rugged. It has a lot of really rugged terrain on its surface, and it's very likely to be very hostile to life. Then we have Ariel. And Ariel is a lot more beautiful in this game than Miranda, and it's also larger. It's 579 kilometers in radius, but it's also tidally locked to Uranus, so that means that it always has the same side facing Uranus. There is also quite a large tidal force here that is not actually shown to us right now because I disabled the tidal heating, but I'll show it to you later on. So this will actually be one of the potential targets for terraforming when we're actually going to start it. And what is special about this particular satellite? Well, it's about 50-50 composition in terms of ices and silicates. So there's about 50% of its mass as ice and 50% of its mass as rock. It also has a lot of various features on its surface, including craters, which suggests that there's really no atmosphere here. But we do know that this is actually one of the few satellites of Uranus that does seem to have some CO2 or carbon dioxide coming from its surface. We don't really know where it's from, but possibly from the inside. So there's some CO2 and there's also some water in it. So that's already a good sign for if we want to try to terraform this. Next on the list is Umbriel. So this is a satellite that is actually somewhat blue in color. I'm not sure why it's not actually as blue here. You can see blue on the side here, but I think that's actually because for some unknown reason there's atmosphere here. There shouldn't be any atmosphere. Let's remove it. This has no atmosphere. I think this is actually an addition that shouldn't be there. So anyway, Umbriel, just like the previous satellite, is basically an icy, rocky structure. It has a little bit more ice than the previous satellite we've taken a look at. This is actually about 60% ice here and about 40% rock. And in every other sense, it's actually very similar to Ariel. There is quite a lot of features here, a lot of craters, a lot of various structures that were, you know, based on collisions with other objects. But overall, it's quite similar. It's basically a rock that is 60% ice and 40% rock. But what is interesting about this is that it actually has a very, very low albedo, and I'm kind of wondering if this is represented here as well. The albedo here should be actually much lower. It's about 10%. So it's actually one of the lowest albedos in our solar system. In other words, this object does not reflect light very well. It absorbs a lot of the light, even though it's so far away from the sun and it won't actually influence it as much. But if it was closer to the sun, it would actually be very, very hot. Anyway, let's look at the next object, and this is, of course, Titania. And Titania is a little bit more massive, a little bit larger. It's about 789 kilometers in radius. But in every other respect, it's very similar. It's a little bit of a rock and more so ice. And interestingly, we actually have detected a possible very, very tiny CO2 atmosphere on this particular satellite, even though it's not represented here, but there might be some CO2 atmosphere, because CO2 is one of the few gases that will not be able to escape into the space as easily due to low gravity here. And of course, don't confuse Titania with Titan, another satellite of another gas giant. This is Titania. This is a very different character from a different book. This is actually from A Midsummer Night's Dream by William Shakespeare. And the name Titania was actually from the Queen of the Fairies. I believe. Anyway, so Titania is interesting because we think that possibly on the inside of Titania there might be even a liquid ocean. There's actually, if there's enough methane and water on the inside and enough pressure, you might actually have a liquid ocean, which, you know, this is where your imagination may go wild. It might have life in there as well. And this ocean might be even up to 50 kilometers in thickness or in depth, but the temperature there would be around 190 Kelvin, which is something like minus 200 degrees Celsius, which is actually really, really cold, but you never know, there might be some life there. Anywho, so this is Titania, and we have another satellite right here on the outskirts, and this is Oberon. Now, for some reason, this also has atmosphere in the game, so we're going to remove this because it has no atmosphere. But anyway, Oberon is 761 kilometers in radius. It's a little bit more massive than other satellites, but not as massive as anything else in the solar system, including our moon. But other than the size and the mass, it actually is very, very similar to other satellites here. So it's about half ice, half rock. It's very similar to Titania in that it might actually also have a liquid water on the inside, just below all of this ice here, very close to the core. It might actually have liquid water inside there. And of course it will be very, very cold as well. So these other satellites we're going to be taking a look at and trying to terraform them. So let's actually open up a new solar system. We're going to choose the solar system with major moons right here, and we're going to get rid of everything that we do not need, including our home planet of Earth and everything else here. Now that's obviously to make the game run a little bit faster, because if we don't remove them, the game will be very, 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 very slow. Now I need to also remove Saturn and Jupiter and possibly Neptune and everything else in this particular region. I am also going to enable tidal heating, and we don't need the collisions. We need tidal heating and also tidal evolution, because we are going to be using as much heat as we can get. Pluto, go away. And because this is so far away from the sun, this is actually really, really far, but look, this is actually what the sun looks like from Uranus or from any of its satellites. But nevertheless, we're gonna try to terraform these 4 satellites, and I believe they are Titania, Oberon, Ariel, and Umbriel. They're very similar. They're very alike in every respect, except for, of course, the size. And this is their beautiful orbit. Look at how beautiful this is. This is actually, if you were to stand on Uranus, this is what you would look like in the night sky. If they were like losing material or something, there'll be this beautiful cascade of orbits. Now this is unique because Uranus and all of its satellites orbit in this fashion, a 90-degree fashion to its actual orbital path. Now this actually creates a slight problem. If and when we are able to terraform these satellites, they will actually have a very extreme season. Uranus takes about 84 years to orbit around the sun, which means that 40 years, or let's just say Umbriel, 40 of those years, you'll be facing one of the sides constantly toward the sun, and that side will get superheated. Even though it's so far away from the sun, it will always be that one side. The other side will stay cold. Now, the other 40 years, it will be obviously the opposite. This side will be very cold, that side will be very warm. But that's something we'll worry about later after we actually terraform this. Now, the easiest way to terraform these particular satellites is to go into the atmosphere and basically put up a big number here. Let's just put up a number like 1 times 10 to the power of 20 kilograms. This will give us a ridiculously high greenhouse effect. Now let's do this for every other satellite, and you'll see what happens in a second. So I've just added atmosphere to Oberon, Titania, Ariel, and Umbriel, and look at how beautiful all 4 are. They all have different color atmosphere. And now let's look at what's happening with temperature. So the greenhouse effect has increased dramatically, but we're actually going to decrease this very soon. And what we're going to do is we're going to wait for this to get closer to the temperature at which ice melts, which is 0 degrees Celsius. But before we do that, let's actually add a few things. So, Umbriel, you're going to receive a present from us, and that present is going to be a little bit of water. You're going to get a little bit of water, and you're also going to get a little bit of organics, but possibly a little bit more water. It's not changing. Oh, here we go. It's changing a little bit. Okay, there we go. That's looking a little bit better. There you go. There's this. This is your ice. It should already have ice on it anyway, but this is gonna give it a little bit more ice. Now that is Umbriel. Let's take a look at Ariel. Then let's do the same to Titania. We're going to add a little bit of water to it, so that it does look like it has oceans when we're actually done with it. And even though it's actually technically already water, but we still need to add this manually just so it looks more terraformed. And finally, Oberon, you're the last. Okay, now that they actually have atmosphere and water, we just have to wait for this number right here to raise dramatically, and then at this point we're going to decrease the atmosphere and try to stabilize the temperature here. So otherwise, if we were to just get this to, let's just say, surface pressure of 2 or 3 atmospheres so that the greenhouse effect is large enough for them to warm up, what would happen is we would have to wait for like years, and I don't think we have enough time to wait. So let's just accelerate time and wait for this to get to a slightly warmer temperature. And meanwhile, watch the orbits. Look how beautiful this is. This is pretty cool. This is very mesmerizing. It's the only planetary body in our solar system that creates such a beautiful vortex of orbits. Now, because Ariel is actually the closest to Uranus, it is going to get more tidal heating, and it's actually warming up a lot faster than other satellites. And so this will be the first that will acquire that terraformed like state. So I'm gonna zoom into it right now, and this is when we're gonna start stabilizing. You can actually see that it's already kind of turning. There's already atmospheric clouds here, and it's already turning more liquidy, so it's getting close to that melting point of ice, and it's about to get blue or dark blue oceans. And this is when we're going to do some little bit of math and try to estimate how much there we go, how much greenhouse do we actually want here. And the effective temperature is minus 240 degrees, and that means that we want to have greenhouse effect of about 220. So let's decrease its surface pressure to about 10 atmospheres and see what happens. Maybe 8 atmospheres. There we go. That should be good enough. So now it will have a really excellent stable temperature, and look at that. It has the oceans, it has the atmosphere, and it has the beauty of a terraformed world. And it's actually looking more green already. Whoa, didn't expect that at all. Not sure why it's looking more green, but that's good. I'm not going to complain. It's already possibly getting life, but obviously this is going to be a very dark type of a Terra-like world, because first of all, it's so far away from the sun. Second of all, it actually has a very high tidal effects from Uranus being so close. So there's going to be some crazy ocean tidal waves here. There's going to be a lot of earthquakes, but some people might enjoy that. That's kind of like, you know, extreme Hawaii type of thing. So this is a planet for you if you like that type of situation. And we have these red atmospheric clouds, very beautiful red atmosphere. Let's actually see what it looks like from the actual surface. Oh, look at that. Look how beautiful this is. And there we go. This is kind of what the surface of the satellite looks like. And this is Uranus right there. And next is Umbriel, and it's already acquired enough temperature as well, so it's already terraformed, has the clouds, it has the atmosphere, and it has the liquid water. And look at that, it's also kind of greenish, which is perfect. It's excellent. We're already getting some life on the planet. Some trees in there, algae and stuff. And this is a terraformed version of Umbriel. It's going to get a little bit warmer, hopefully. It's currently at average temperature is 2 degrees Celsius. We're aiming at around 10 to 15 degrees Celsius. We're gonna wait a little bit and see how much it warms up. And it has 8 atmosphere pressure, which is approximately the same pressure as at a depth of 80 meters underwater, which is not really nothing you'll actually complain about. It's not very pressurized. Then who's next? We have Titania, which is still relatively cold, and Oberon, which is also very relatively cold. And the only reason why Ariel and Umbriel heated up so fast is because of the tidal power from Uranus. Now this one here has a little bit less tidal power, so there's and by this one I mean Umbriel. Umbriel has a little bit less tidal power, so the waves and the earthquakes will not be as pronounced as Ariel. So this is a slightly more prime real estate here, because it won't be as dangerous to live on it, but nevertheless the earthquakes will still be quite powerful. Then let's look at the next satellite and wait for it to warm up as well. And the next on the list is Oberon. It's about to reach that 0 degrees Celsius limit as well, and here we go. So let's stabilize its temperature. We're going to decrease the atmospheric pressure to about, let's just say 12, possibly 11 atmospheres, and zoom in and check it out. So this is Oberon, and look at that, just like the other satellites, has the water, the atmosphere, clouds, and getting green. I wonder if this is actually a new addition in the game where things are getting a little bit more green, as in they're actually acquiring a life. So beautiful, this is gorgeous. They all look very Earth-like, and the temperature here will stabilize around 5 degrees Celsius. We're gonna try to change it a little bit later. And lastly we have Titania, and Titania already got a little bit warmer. It's at 8 degrees Celsius, and just like the other 4 satellites, it's totally green or greenish, has water, has liquid water, that is, atmosphere, and looks beautiful. So here we go, to have 4 satellites of Uranus terraformed and ready to receive colonists. We have all 4 of them. They all seem to have acquired green color, which is excellent. It means that they're possibly terraformable and have capacity for life. This one looks a little bit different. Ariel looks a little bit different. It's actually quite more yellow and red, so this is more like a desert world possibly, or we don't really know what it's like, but it's a little bit more hot and a little bit more extreme because of the earthquakes and tidal waves. And Umbriel is a little bit more cyan and blue in color, so it's possibly because it has more liquid water. Anywho, so we've succeeded in terraforming them, and now we can also obviously terraform Uranus, but we've actually done this before in the previous video, and I'm posting the link for this in the annotation. So if you want to take a look at that, do so, because it's a more difficult process. But having terraformed 4 of these satellites, let's actually talk about the fact that they will have a 40-year-old cycle, 40-year long summer and 40-year-long winter. Now that is a crazy cycle. That means that if your house is located on the dark side right here, for about 40 years you'll be in complete darkness and you'll be pretty cold. So this is probably one of those situations where you want to buy a prime real estate for about 40 years and then sell it for 40 years to someone else. So yeah, the actual annual cycles here, or the actual seasons, are quite extreme, and this is actually very unique to Uranus and very different from other gas giants and other planets in our system, and mostly because its rotation is actually 9 degrees to its orbit. So because every satellite orbits in that way, they always have this one face facing the sun and the other face facing the dark side. So for that reason, it's actually going to be very difficult to live on these terraformed satellites. But other than that, here we go. This is really it. And if you enjoyed this video, please subscribe and like this video, and also check out some of the other videos like this one here where I actually did the same to Saturn, or this one here where I did the same to Jupiter. And here's the one where I basically terraformed a bunch of other planets in our solar system. If you would like to see more, or if you have a suggestion, please leave a comment and also tell me what you actually think or what you would like me to terraform next. I think next one will obviously be Neptune, but we never know. There might be a better suggestion. Anywho, I'm going to pause this video here, and please remember that this is not Uranus, this is pronounced Uranus, and hopefully you'll remember, if anything else, you'll just take that from this video and learn how to pronounce it properly. Thank you for watching, please subscribe, and game you later. Bye bye.